Welcome to week 7 with Mrs. Bibb in Algebra 1 Honors. Please make sure to fill in your table of contents. Complete your weekly warm-up. In this week's lesson, we're going to be reviewing some skills that you've had to use in the past. I'd like for you to go to your textbook and find the definitions for relation, function, domain, range, independent variable, dependent variable, and write those definitions here. On Student Journal 62, I just want to remind you about the vertical line test. Remember, if you have a graph, to decide if you have a function, you perform the vertical line test. Some teachers call it the pencil test, where you roll your pencil across the graph. If that pencil intersects that graph in more than one place, like this one here, then it fails the vertical line test. So this one is a function because no matter where you could draw a vertical line, you're only going to go through one point on the graph. This one is not a function because the only place you could draw one line and only go through one point is here on the end. So function, not a function because of passing and failing the vertical line test. The book defines domain and range as set of all possible input values for domain, set of all possible output values for range. Please remember that your domain involves the x's and your range involves the y's. X, Y, domain, range. Don't forget that. So we're going to determine whether this relation is a function. Looking at my table, I'm looking for repeating of x values. Do I have any x values that repeat? Yes, I do. So this is not a function. Is this a function? Yes. And the reason no x values repeat, or every output is paired with exactly one input. Is this a function? Would it pass the vertical line test? No. Fails the vertical line test here, so how about this one? Yes. Number 5, I want to find the domain and the range. Remember from our summer work, this is a discrete graph. This one is sort of continuous. It actually does stop on the ends, but it is sort of continuous. And for this discrete graph, I list the values of the domain and range. For my continuous graph, I have to have inequalities for domain and range. Okay, domain are my x values. 0, 4, x is 0. 1, 4, so x is 1. 2, 4, x is 2. 3, 3, x is 3. 4, 3. 5, 3. The range is my y's, so 0, 4. 1, 4. 2, 4. 4 was the only y I said here. 3, 3. 4, 3. 5, 3. 3 is the only y I said. So I only have two values that represent my range in this problem, and that was the value 3 and 4. Let's look at the next one. My farthest left point, left and right, are your domain. Up and down are your range. My farthest left point is -3, and +3 is my farthest right point. My lowest y value is 0, and my highest y value is 3. So let's talk about domain. Domain is your x's. How far to the left does it go? From -3 to 3. And you put x because x is your domain. You put equal to symbols because these are closed circles. For my range, I'm going to put y's. What's my lowest? Because these are smallest to largest, smallest to largest. What's my lowest y value? My lowest y value is 0. And what's my largest y value? 3. So that's my domain and range. Number 7. The function y equals 12x represents the number of pages of text a computer printer can print in x minutes. Identify the independent and dependent variables. I always remember that y depends on x. Y is the number of pages. So y depends. Y is dependent. So the dependent variable is y, which stands for the number of pages. That means x is my independent variable, and it stands for the number of minutes. Now we're going to find the range. So my range is 12, 24, 36, can't read my own handwriting, and 48. It says, using the function 2x plus 4y equals 12. I don't believe number 8 is on your student journal page, so if you'll find you a place to fill in number 8, it can be on any spot that you can find on these pages. It says solve the function for y. That means to get y by itself. So I'm going to subtract 2x. 4y is going to equal negative 2x plus 12. Divide by 4. Y is going to equal negative 1/2 x plus 3. Now I'm going to find the domain if the range is 0, 1, 2, and 3. So it's kind of in reverse. I know the y values this time. I know 0, 1, 2, and 3. I'm trying to find those x values. So y equals negative 1/2 x plus 3. Y is 0. I'm going to subtract 3. I'm going to multiply by negative 2. So 6 is my first domain value. So my domain is going to be 0, 2, 4, and 6. That's the answer to number 8. Now, this is still page 27. It says it's not a student journal page. Please copy this down for student journal page 27. If there's space somewhere, you can copy it. If you want to use a sheet of paper, it says please use a sheet of paper. But if there's space somewhere on these pages, you are welcome to copy it there. Please copy those tables. It says, how do you determine if you have a linear function given an equation, a table, or a graph? If you have an equation, there's no exponents on y other than 1 or x. It must have a y in it to be a function. It can't be x equals. It may not just have an x in it. This is a vertical line, which fails the vertical line test. For the table, it must have a constant rate of change. No x value can repeat. For a graph, it must be a straight line, and it must pass the vertical line test. All functions, not just linear functions. So I'm saying here that all functions have to pass the vertical line test, not just linear functions. All of them are continuous graphs. So I'm going to have the x and the y with inequalities for all of these. When I have a continuous graph, that's how I'm going to have my domain and my range. Okay, let's look at number 1. Is this stopping? No, it's going toward negative infinity. So I can put negative infinity. Whoa. And is it stopping as you go to the right? No. I can put positive infinity. Probably the best way to write this would be from negative infinity to positive infinity. If you put this, I'd be okay with it, but that's the best way. For this one, what's the smallest y value? What's the lowest it goes? It looks like negative 2 is my lowest y value. What's the highest y value? Are there any other points where this would go up and stop? No, it goes forever. So there's an answer. Best answer is from negative 2 to infinity. Okay, let's look at number 2. These do not appear to keep going forever. So the farthest left my graph goes is negative 1.5. The farthest right my graph goes is 2.5. So from negative 1.5 to 2.5. How far up and down? What's the lowest y value that I have on my graph? Negative 3. What's the highest y value I have on my graph? I have a y here of 2.75, but I also have a y here of 3. Which one's bigger, 2.75 or 3? So it ranges from negative 3 to 3 for my range. And again, the best answer would be interval notation. I'm going to put brackets since they're all numbers. I don't have infinity. Negative 1.5 to 2.5 and negative 3 to 3. So domain and range. And then this last one, I don't have any ordered pairs, but look, this continues forever towards infinity for x and towards negative infinity for y. But what is this ordered pair here? 1, 2, 3. 1, 2. It looks like negative 3, 3. So what's the farthest left this thing goes? The farthest left it goes is to negative 3. What's the farthest right it goes? It goes towards infinity. Okay, let's do our range. How far up and down? What's the lowest point that it goes? It goes towards negative infinity. And what's the highest y value I have? 3. So there's my domain and range. Let me write that in interval notation. Negative 3 to infinity, and then from negative infinity to 3. Domain and range. And that may be it for this week's lesson. Make sure. Yes, what's left is practice. Have a great day.